First thing, just so that you guys know, we're going to start on section 1.1, which starts on page 4. And just so that you guys know, it starts on page 4. And while you guys are getting your stuff out, the first thing that's going to happen is I'm going to tell you about the first 4 parents that we're going to refer to. They call them families in there. I've heard them referred to as parents. I like to call them parents because then that way when we change them, then we have a child. Okay, so that's kind of what we have between the 2 different ones. So the first family or the first parent that you guys are going to look at is called a constant. And the way it looks is it will look like f of x equals, and then a number. And the parent one is going to be the number 1. Now, the reason why it says f of x is because we are in what we call function notation. That's the same thing as y equals. Okay, but when it talks about function notation, function is a machine. And much like downstairs, you've got the different water and Gatorade machines or Powerade machines. I don't remember what's down there. But they're 2 different machines, along with an ATM machine that's right next to it. All those are machines. X is the variable, but you'll notice on the constant one, there is no variable. It's just a number. Okay, and that's all it's going to be. What it looks like when it's graphed, you'll see, do you guys remember what these are called? Anybody remember what that's called? Axes, right? X and Y. Okay, coordinate plane, right? Now, I'm going to use blue to kind of show this one, but the constant one, the f of x equals 1, would be right there. Can everybody see the blue? Is that okay if I graph in color, or can we not see that? Okay. Now, one of the things that I want to point out to you guys is this. I have, if you notice, an x and a y here on my axes. The reason why I do that is so that you know which one's the axis and which one's the line. Okay, if you'll notice for constant that this thing is a horizontal line. We're just going from left to right. It's not slanted, at least hopefully not. Okay, it should look straight. We are straight going from the left to the right. That's what a constant equation looks like, or constant function looks like. All right? Everybody okay with constant? So the first family will look like a straight line left to right. The second family is called linear. If I say the word linear, what word do you think of? Yeah, and you should, okay, because that's what it is. So the function itself is going to look like f of x equals x. That's what the parent looks like, or is written like. And then as far as what the graph looks like, and I know you guys spent a lot of time in Algebra 1 doing this, but you would graph something that looks like this. If I were to ask you to draw the line y equals x, okay, that's having an intercept of 0, because there was nothing in the b location, and a slope of 1, which means up 1 over 1. Right? That would be what is in the m position. Do you guys remember y equals mx plus b? It's been a while since you've seen it, but that's exactly how I got that picture. Now that is the family, or that is the parent for the linear function. Okay, so that's what it looks like, and then after that, we can adjust it. Okay? Third family that you're going to have is absolute value. Anybody ever heard of absolute value before? What's absolute value look like? How do you know it's got absolute value in it?
Because it's got the two.
Got like the two like things, right? Those two sticks. I don't know what to call them other than absolute value signs, right? But they look like two sticks. Okay? in the function notation, it would look like this, the absolute value of x. Okay, absolute value symbols, just so that you guys remember, are in fact grouping symbols. So if you hear me refer to grouping symbols, that is a grouping symbol. It's a built-in one. Okay, so we have to do everything inside there first. All right, how or what an absolute value looks like is it looks like a V. So it comes out that way and goes out that way. Okay. So the absolute value function will look like a V, not a U. It's not rounded at that corner there at the origin. That's actually a V shape. Okay? So that's what the absolute value looks like. Looks like a V. Then the fourth and final one that I have for you guys today is known as a quadratic. And that's f of x equals x squared. Now I do realize that we can have higher exponents than that, but we're only going to deal with the exponent of 2 this time. Okay? So if it's x squared, that's a quadratic. What it looks like is anybody remember what a quadratic looks like? A U, right? We talked about it yesterday. Yeah, it's a parabola. We talked about it being, half of the McDonald's symbol. Okay? But that's what they should look like. Now, as far as today goes, when it comes to graphing these things, I'm not going to be that picky with you right away. I just want to make sure that you're getting stuff in the right locations. Now, these are the parents. Okay? This is those four are the four that we're going to base everything on. Okay? Now, the next thing that we're going to go through is we're going to go through all the different ways that I can transform them, meaning to change. If I were to take this chair right now and move it to here, did I change the size of it? No. What did I do to it? I just moved it, right? How about now? Did I still move it? Did I just move it, or did I change the size or shape of it? I just moved it. What about now if I do this? What did I do? Okay, I flipped it over, right? I changed the location. All of those different types of things are transformations. A transformation is nothing more than changing it. Okay, that's what it is. It's to change. The thing I'm going to give you now is I'm going to write up here a template as far as where things are going to be located at and what they do. It's going to get a little messy. Okay? It's going to look a little confusing at first maybe, but trust me, it'll be okay. The first thing that you're going to have, or you could see, is you could see that symbol. Does anybody know what that symbol is? I hear him can't speak. I'm hearing subtraction symbol, right? I heard somebody say that. How about negative? Could that also be a negative sign? Okay. Could it be a fraction bar if I start writing stuff on top and the bottom? Right. This is actually a negative symbol. Okay. What that's going to tell us, that symbol right there, is it's going to tell us if it's a reflection over the x-axis. Now here's what a reflection does. By the way, any of you use reflection today? Any of you use a mirror today? I hope all of you did, okay, and not just to get ready, but if you drove here, I hope you used your mirrors. If you didn't, let me know so I know not to ever drive around you, because I don't want to get hit by you. Okay? But reflection is nothing more than a flip. So here's what it's going to look like for you. Okay? For instance, tonight, Minor High plays West Fargo in football in West Fargo. It's on TV if you can't make it. But hopefully our team gets to see a lot of this. Okay, this is the symbol for touchdown in football. Okay? What shape does it look like out of the ones that we've already used? Like if you connect it all the way across to here. Looks like the quadratic, right? Looks like the U. If I flip it over the x-axis, instead of opening up, it's going to open down. That's what happens. Okay? So instead of opening up, it opens down. That's what a reflection over the x-axis does. If it was the v, like the absolute value symbol, instead of opening up, it's going to open down. That's what it does. So a reflection over the x-axis just flips it over. Okay, that's the first part. The second piece. Now, I use what I call shadow boxes, even though they're probably not shadow boxes per se, but they're little dashed boxes. And the reason why I use those in this particular context is because with the calculators that you guys hopefully should be getting sooner than later, if you guys ever get one of the new TI-84s or the TI-84 color screen ones, they actually use that symbol when you want to insert things into pieces. They use it looks like a little a dotted box. Okay? So that's why I'm using it. It's just because it looks like that. If there is a number in that location, which means that it's going to be multiplied to on the outside, this is what we call a vertical stretch or shrink. Now here's what they mean by a vertical stretch or shrink. If I were to take something, how many of you guys have ever had Laffy Taffy before? Like everybody, okay? If you think about Laffy Taffy, either the little ones or the big long ones, whatever. If you were to grab a Laffy Taffy on the top and grab it on the bottom, so probably the rope ones are a little bit more soft than those hard ones. If you were to pull this way, what's it going to do? It's stretching out, right? It's getting narrower. It's getting skinnier, okay? When it talks about a vertical shrink, it's like me grabbing the top and the bottom and pushing it together. What would happen to the Laffy Taffy if I squished it? Okay, it shrinks out or it gets flatter, doesn't it? Okay, like a pancake. That's kind of what those things would do. So a vertical stretch is going to make my graph look, instead of being out here, it's going to be narrower. But a vertical shrink would make it look wider. That's what's going to happen. Okay? Now, how do you know which one's which? If the number in that spot is bigger than 1, it's going to be a stretch. If the number in that spot is less than 1 but greater than 0, it's going to be a shrink. Now, I want you guys to take 30 seconds at your groups, and I want you guys to ask each other or tell each other what types of numbers are between 0 and 1. On your mark, get set, go. What types of numbers are between 0 and 1? All right, and because I'm still learning everybody's names and I don't remember anybody's, so, Hannah? Hannah, right? No. Haley. I knew I was going to do that wrong. Haley, what'd your group talk about? What is the number between 0 and 1?
Like 0.1, 0.2.
Yeah, exactly. Decimals. I heard some groups talk about decimals over in here. Anybody say fractions? Okay, a lot of times you'll actually see them as fractions rather than decimals. Here's what you got to be careful about. If that fraction is 5 halves, would 5 halves be a stretch or a shrink? It's a stretch because that's bigger than 1. Okay, so be careful. So what that number does, again, if it's on the outside like that, if there's 1 there, then we have a vertical stretch or a shrink. If there's not 1 there, guess what you don't have? Then you don't have a stretch or a shrink if there's not a number there. Then the next thing I wrote up there, and you may have missed it because I didn't say it, but I started with a parenthesis. I am writing a grouping symbol. These grouping symbols can be parentheses, they can be fraction bars, they can be square root symbols, they can be a lot of different things. I'm going to use parentheses for this one. However, you could change it if you want to put anything else, but that's what a parenthesis is going to, or a grouping symbol is going to start with. Okay? Then you'll have another possible negative sign. If the negative sign on the outside said reflection over the x-axis, what do you think a negative on the inside is going to be? Good job. This one's going to be a reflection over the y-axis. Now, here's the catch. As I'm standing here again, showing you my parabola like this, it's me. Okay? If I reflect it over the y-axis, look what happens. Okay, watch here for a second. So here I am parabola, right? If I reflect it over the y-axis, did anything really change? No. Okay, that's the one part about this that you got to be careful with. This is the same as this. It's just you get to look at my front rather than back. Okay? But according to the graph, it's really hard to tell that. So when you're looking at that particular part, the only way you're going to know is just by the sign. If I were to give you two pieces and say what transformation took place without giving you the equations, it might look like nothing. In reality, it was a reflection over the y-axis. So you got to be careful. Okay? Y-axis reflection goes like this. All right? X-axis reflection is up to down. Y-axis is left to right. Okay? Then here's where it's going to get real goofy because I do not have enough room. Here's another shadow box. Another number. Anytime you see a shadow box like that or a dash box, it's a number. Now I got to make another arrow. I'm so sorry. This is going to be a horizontal. Stretch or shrink. So vertical was me grabbing it from the top and the bottom and pulling or pushing. What's horizontal going to be? Grabbing it on the sides and either stretching it or shrinking it. So here's what I want you to think about. What is the graph going to do if I grab the sides and stretch it? Would it get wider or narrower? Anyone want to take a guess? Wider, right. If you were to grab my arms and pull this way, would the parabola get wider? Yeah. Okay, what about if you were to push on my elbows to make it go, to shrink it? Would my parabola get wider or narrower if you were to push? It should get narrower. So here's the thing what you'll see eventually. A vertical stretch, which makes the thing get narrower, does the same thing as a horizontal shrink. A vertical shrink does the same thing that a horizontal stretch does. Okay, so they do the same things, they're just in different locations. Now, it's a horizontal shrink if that number is greater than 1, and it's a stretch if the number is between 0 and 1. Notice the difference between the two? I just switched the different parameters. Okay, those 4 parts are the hard parts. Now comes the last 2, the easiest 2 of the bunch. Then you'll have a variable. Most times we use x. That does not mean times. Not in algebra. Okay. Then you could have a plus or a minus and then a number. A plus or a minus on the inside. A plus goes left and a minus goes right. That is the shifting part. So when I took that chair originally and moved it left and right, up and down like that part, that's what I'm doing here is I'm just transforming it, or I'm translating it left and I'm translating it right. You, for me, keep it in simple terms. If you just tell me left and right and then by how many, that's okay, that's fine. In a college level setting, here's what they would ask you to do. That would be a horizontal translation, 3 units to the right. make it sound like you're a lot smarter than you need to, when all you really have to tell me is write 3. Okay, keep it simple. Then the grouping symbol closes off, and then you have one more key piece. Anybody know which way we can go now? Up and down, right? Plus goes up, minus goes down. Now I know that was really tight there. That says down. This thing really doesn't give me enough room. But this template, you guys can answer things for you for the entire year. This, honestly, all I have to do is change the parentheses to any type of grouping symbol I want, and we have everything right there on that screen. That will answer things for 6 different chapters we have. Okay? What it's going to ask you to do for your assignment today is the first part it's going to ask you, tell me what family this belongs to. So it might give you a picture and say, what family does this belong to? That's all you have to do. Tell me what family. You only have 4 options, so you have a 25% chance of getting it right without even knowing. And then the majority of your assignment is going to be using this, and it's going to say, sketch the graph of the parent and the function, and I'll show you what they mean by that, and describe the transformations that take place. And I'll show you how to do that using this template. Okay? So, first things first. If I give you this picture, what family does that belong to? The blue line. Good. What family does this belong to?
Linear.
How'd you know? Okay. What about this family? How do you know? Because it's a V and not a U. And what about this one? Constant. Okay. And the last one? Quadratic. So just by looking at it, you should be able to tell what family it belongs to, right? Okay, good. Then, the harder parts. Here's what it'll say, is it'll give you an equation like this, and it'll say f of x equals negative absolute value x plus 3 minus 4. Okay? Here's what it's asking you to do in the directions. It says to graph the function and its parent. So how many graphs should you have on the picture? 2. And then describe the transformation that takes place. Now, in my opinion, I think it's easier to do the transformations first, or describing them, because that helps us draw the picture. So now, that template that I gave you, here's how it works. Is there a negative sign on the outside? Yes. So that means that we have a reflection over the x-axis. Outside is x. Okay? Is there a number multiplied on the outside of the grouping symbol? Is there a number in that spot that I just put that arrow to? Is there a number right here? No. It's a number 1, but 1 wasn't part of it. Okay, so that's not a number there. How about here? Is there a negative sign in front of that x? Is there a number in front of the x? So those parts don't exist in this problem, just so you know. Okay? Is there an add or subtract on the back side of that, inside the grouping symbol? Yeah. What's a plus 3 tell you? You're going left 3. And is there a number on the outside being added or subtracted? What's a minus 4 tell you? Down 4. So you have all the tools right there to make this graph go. So what was the parent again? What's an absolute value look like? Looks like the V. So here's the V. There's the absolute value. Okay? Now, here's how I use the transformations in order to make my picture. You guys have been taught over the years lots of different ways to graph things. If you can't physically handle this part, could you take and put numbers in for x to find y's and plot ordered pairs and connect the dots? Yeah, you guys have done that before. But for this particular thing, here's how it's going to work for me. Did you see how it says left 3? Right? 1, 2, 3. Did you see where it says down 4? 1, 2, 3, 4. So that little dot right there is representing where the V should be. Okay? In which way should this open? Should it open up or down? How'd you know? Now, should it be wider, narrower than the original one? Or should it be the same? As best you can, the same. So if you notice what I did, I used the transformations to create my picture without having to put it in a calculator and without having to plot ordered pairs. Again, what I did was, have you ever seen like when you put a picture into like a Word document and you want to move it to a different spot, the hand tool, it comes up and you grab it, it looks like you grabbed it, and then you can move it around and then drop it? That's exactly what I did. I grabbed it, moved it, flipped it over, and dropped it. That's all this is. If you can handle one like that, you can handle any of the ones that I'm ever going to give you. Realistically, the only other thing that I would have done is I would have given you one that had 4 transformations instead of 3. 4 is about the max that we give you. What do you think? How do you feel? Confused a little bit? Okay. How is the template? Do you understand how it works? If you go right along the row and just see how, if it's there, you have it. If it's not there, you don't. Okay, let's try another one. Michael, one of the Michaels, give me a parent. Mm-hmm. One of the families. Huh? Quadratic? Okay. So if we have f of x equals 12, not that big. Okay. 12 x. Give me a number. Huh? Just 3. Minus 3 squared. One more number. Plus 2. Okay, so now with this problem, here's what I want you to tell me first. And we already know what the answer is for this one, so that part should be easy. I want to know the parent. I want you to describe all the transformations. I'll even give you a hint. There are 3 of them. And then graph both of them. So that's what it's going to ask you to do. It's going to ask you for those parts. Okay, so I'm going to give you a little bit of time to work on it.
What's the assignment?
I haven't told you that yet. Ha ha ha. McDonald trying to get ahead. guys are starting to finish up with this problem, okay, work with your group. Compare your answers, see how you guys did. See what you guys got.
It's quadratic.
Oh, okay. When I see it like that,
Yes, me?
yeah, I didn't write it like that. I wrote them all separately.
Oh, gotcha.
What? How did you write that? So the boxes are the numbers. With the -3, you square it, it becomes a 9, so it should be, no?
Nope, because you would have to square the whole thing, so you're not even doing that, you're not squaring it at all. The only thing the squared tells you is that the parent is a quadratic.
Oh, okay, so all of this is good?
That's right.
Sweet.
Okay, to answer the first part, what is the parent? Quadratic. We should have got that right because Michael said quadratic to begin with. Okay. Then, as far as the transformation goes, what's one transformation that took place? Okay, I heard vertical stretch. That's the first thing that I heard. By how much? By 12. Here's what that means to you guys. When we're vertically stretching it by 12, that means that we're going up faster by 12 times as much. It's like me saying, you know what, I'm going to run a mile, you're going to run 12. Okay? There's a big difference there. Or if you think about when you multiply numbers, 1 times 12 is 12, but 12 times 12 is 144. It's going to be going up a lot faster. So my graph should be narrower. That's what's going to happen. What's a second transformation that takes place? Right 3. Good. Now I had a question, and just so that you guys understand this, a couple people asked me this about the squaring part of it. The squaring only really tells you that it's a quadratic. It's not, the answer is not 9. We're not going right 9. We're going right 3 because 3 was in that spot. Okay? You're not actually squaring that out. And then what's the third one? Up 2. Now again, just to sound a little more technical, if you were in a college setting, your professor might say something like this for that last one. That is a vertical translation 2 units up. So they went vertically, up and down, and then they said up again. I don't understand why it's like saying it twice. And so just up 2 is fine by me. In your groups, are you guys comfortable with how you got that? Okay? Now, the graphing side of it. Hi, Miss Farmer.
Haley?
The graphing side of it. And I don't know if you guys got to that part yet or not. But the parent should look something like this. That should be my parent. Now, according to your transformations that took place, going by a vertical shift or stretch by 12, I should be a lot narrower, shouldn't I? Should be almost pretty skinny. And then also right 3 and up 2. So if this is the bottom portion, you guys see where I'm putting the red dot? Like Rudolph's nose. I know it's too early for Christmas, but it'll be here before you know it. Right 3, 1, 2, 3, up 2, 1, 2. So it should be somewhere in this vicinity, and it should be pretty skinny. So if you notice what I did, on the picture, the red one is the new one, the black one is the parent, and I listed out the transformations that took place. I did everything that the directions are going to ask you to do. And what do you guys think? Some of the pictures are not going to be this complicated. Some of the problems are maybe only going to have one transformation instead of 3 of them. I decided to hit you with one that had 3 of them to give you the worst case scenario. A lot of your questions might only have 1 transformation taking place, or 2. Okay? So there's going to be some of them that are a lot less involved than this one is. Does that make sense? Like it might only have right 3, so you just move it over 3 units and there it is. Or it might just have up 2 and that's it. Or it might just have the vertical stretch. Okay? But then there's some of them that are going to be where they have a little bit more. How do you guys feel? We'll see? Okay. So here's what I got for you. On page where'd you go? Oh, you're right here. So again, when it says multiples of 3, do we understand what multiples of 3 are? Okay, because in the past, here's what's happened. I've had people go, multiples of 3 are 1, 4, 7, 10. What are they doing wrong? They're just adding 3. Okay, so it starts at 9, and 12, and 15, and 18, and so on. Okay, it looks like a lot more than what it really is, though. Just so you know.